Good morning, students. Today we are going to see an important topic in Unit 5, Nanochemistry. What do we mean by nanomaterials? Nanomaterials refers to the materials whose average size is less than 100 nanometer. And the nanochemistry is a branch of material science or chemical science that deals with the various methods that results in the development of nanomaterials, otherwise materials at the nanoscale, and fabricating their different properties. What do we mean by nanoscience? Nanoscience deals with the different molecules and structures at the nanoscale, roughly between 1 to 100 nanometer. Now, what is nanotechnology? Nanotechnology is nothing but which involves the manipulation of various atoms and molecules at the nanoscale. Generally, nano stands for 10 power minus 9 meter. Now, let us see the classification of nanomaterials. How do we classify the nanomaterials? Now, on the basis of origin, that is, with respect to their sources, we can classify them as natural as well as artificial. Now, with respect to their structure, otherwise a dimension, we can classify them to be 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional. What do we mean by 0-dimensional nanomaterials? 0-dimensional nanomaterials are the materials where all the dimensions at the nanoscale, length, breadth, and heights, are point to a particular single dot. That is, otherwise you can say all these parameters are confined to a particular single point. Example, nanosphere, nanoclusters, etc. 1-dimensional. Suppose if any nanomaterials have two external dimensions at the nanoscale and one being at the microscale, means they are said to be 1-dimensional. It has only one parameter, either length or breadth or height at the nanoscale. Example, nanofiber, nanotubes, nanowires, nanorods, etc. 2-dimensional. These are the nanomaterials which have one external dimension at the nanoscale and other two dimensions at the microscale. It has a length and breadth. Example, thin films, nanocoatings, nanoplates, etc. 3-dimensional. These materials display internal nanoscale features but no external dimensions at the nanoscale. They have parameters like a length, breadth, as well as height. Example, nanocomposites, nanostructured materials. Now, let us see the synthesis of nanomaterials. With respect to the synthesis of nanomaterials, there are two different approaches. One is known as top-down approach, another one is known as bottom-up approach. What do we mean by top-down approach? It generally involves physical methods. We start from a bulk material, then the size of the bulk material is simultaneously reduced to the size of the nanomaterials. Now, when you take a bottom-up approach, this involves both physical as well as chemical methods. We start with the atoms